20 facts about the solar system to fall asleep to. Let yourself settle in. Take a deep breath, and let's begin a quiet journey through our solar system, our cosmic home among the stars. Fact 1. The ancient light. Imagine for a moment that you're standing outside on a sunny afternoon, feeling the warmth on your face. That sunlight touching your skin right now. It began its journey 8 minutes and 20 seconds ago. The light left the surface of our sun, traveled through 93 million miles of empty space, and arrived just in time to warm you in this very moment. 8 minutes and 20 seconds. That's how long it takes for the sun's light to reach Earth. When you watch a sunrise, you're actually seeing the sun as it was 8 minutes in the past, a gentle reminder that even light, the fastest thing in the universe, needs time to traverse the vast distances of space. Close your eyes and picture that journey, millions upon millions of miles, crossed in the time it takes to brew a cup of tea. Fact 2. The sun's heartbeat. Now, let's drift closer to that sun in your mind. If you could somehow stand on its surface without being instantly vaporized, you would witness something extraordinary. The sun doesn't shine steadily like a light bulb. Instead, its entire surface ripples and pulses in a slow, cosmic rhythm. These aren't small ripples either. They're waves that rise and fall by hundreds of miles, making the sun gently breathe like a sleeping giant. This phenomenon happens because the sun isn't solid. It's a ball of plasma, a fourth state of matter where gas becomes so hot that electrons break free from their atoms. Deep in the sun's core, where temperatures reach 27 million degrees Fahrenheit, nuclear fusion transforms hydrogen into helium, releasing the energy that makes our star shine. That energy takes thousands of years to work its way from the core to the surface, bouncing around inside the sun like a pinball, before finally escaping as the light that reaches your eyes. Fact 3. The protective shield. As we move outward from the sun on our journey, let's visit Earth again. But this time, let's float high above it, where the atmosphere grows thin and space begins. Up here, something invisible surrounds our planet like a cocoon. It's Earth's magnetic field, and it extends thousands of miles into space, creating a protective bubble called the magnetosphere. This invisible shield is generated by the churning, molten iron in Earth's outer core, spinning and flowing 2,000 miles beneath your feet. Every day, our sun sends out more than just light. It releases a stream of charged particles called the solar wind, rushing through space at about 1 million miles per hour. When these particles reach Earth, our magnetic field deflects most of them, wrapping around our planet and guiding them safely past. Without this shield, the solar wind would gradually strip away our atmosphere, leaving Earth as barren as Mars. But sometimes, when the solar wind is particularly strong, some particles slip through near the poles, colliding with our atmosphere and creating shimmering curtains of green, red, and purple light. The aurora borealis in the north and aurora australis in the south. These dancing lights are nature's reminder that we live inside a protective magnetic embrace. Fact 4. The asteroid sanctuary. Now let's drift further from Earth, past the orbit of Mars, to a region of space that might seem empty at first glance. But as your eyes adjust to the darkness, you begin to notice them. Countless rocky bodies, tumbling slowly through the void. This is the asteroid belt, a vast ring of debris orbiting between Mars and Jupiter. Despite what science fiction movies might suggest, the asteroid belt isn't a dense field of rocks crashing into each other. In reality, if you were standing on one asteroid, the nearest neighboring asteroid would likely be so far away you couldn't see it, even with a powerful telescope. There's so much empty space here that we've sent numerous spacecraft straight through the belt without any risk of collision. These asteroids are remnants from the solar system's formation, pieces that never quite came together to form a planet. Some are just a few feet across, while others, like Ceres, are massive enough to be classified as dwarf planets. They tumble through space in silence, cold and ancient, preserving clues about what our solar system looked like 4.5 billion years ago, when everything was young and still taking shape. Fact 5. Jupiter's ancient storm. And finally, beyond the asteroid belt, we arrive at Jupiter, the giant of our solar system. Jupiter is so large that you could fit all the other planets inside it and still have room to spare. But what draws your attention as you approach isn't its size. It's the Great Red Spot, a massive storm in Jupiter's southern hemisphere. This storm is bigger than Earth itself, and it's been raging for at least 350 years, possibly much longer. We know it's been there at least since 1665, when astronomer Giovanni Cassini first observed it through his telescope. But this ancient storm may have been swirling for thousands of years before that. Imagine a hurricane that has been spinning continuously for longer than the United States has existed, longer than the Industrial Revolution, longer than the Renaissance. Winds at the edges of this storm reach speeds of 270 miles per hour, and the entire massive system rotates counterclockwise every 6 Earth days. As you watch it from a distance, safe and calm, you can see it's actually quite beautiful. Swirls of deep red and rust orange, surrounded by lighter bands of cream and tan. No one is quite certain why it's red. Scientists believe it might be due to complex chemicals brought up from deeper in Jupiter's atmosphere, exposed to sunlight and changed by ultraviolet radiation. The Great Red Spot is slowly shrinking, growing smaller each year, but it will likely continue to spin for decades or even centuries more. A patient storm on a patient planet, moving through space in the quiet darkness. Let these images rest in your mind. The 8-minute journey of sunlight, the breathing sun, Earth's protective embrace, the scattered stones of the asteroid belt, and Jupiter's eternal storm. Rest now, and let the cosmos hold you in its vast, peaceful silence. Take another slow breath, and let's continue our peaceful drift through the solar system, moving outward into the cold reaches of space where wonder awaits in the darkness. Fact 6. Saturn's Whisper. Beyond Jupiter, we come to Saturn, the jewel of our solar system. Even from a great distance, you can see what makes Saturn so distinctive. Those magnificent rings, stretching out from the planet like a cosmic halo. But here's something that might surprise you as you draw closer. Those rings, so vast and beautiful, are impossibly thin. Saturn's rings extend outward for about 280,000 kilometers, nearly 3/4 of the distance from Earth to the Moon. Yet if you were to measure their thickness from top to bottom, most of the rings are only about 10 meters thick, roughly the height of a 3-story building. Imagine a disk of ice and rock particles, each piece ranging from the size of a grain of sand to a boulder as big as a house, all spread out in a layer so thin relative to its width that if you built a scale model where the rings were as wide as a football field, they would be thinner than a piece of paper. These particles orbit Saturn in perfect harmony, shepherded by the gravity of small moons hidden within the rings themselves. As you float there in the silence, watching Saturn slowly turn, sunlight catches the ice particles in the rings, and they sparkle like diamonds scattered across black velvet. The rings cast shadows on Saturn's clouds below, and Saturn itself casts shadows across its rings. A dance of light and darkness playing out across hundreds of thousands of miles. Fact 7. The Sideways World. Now we travel even further from the sun, out to where sunlight grows dim and the cold of space deepens. Here we find Uranus, a planet quite unlike any we've encountered so far. Most planets in our solar system spin like tops, rotating upright as they orbit the sun. But Uranus is different. This ice giant rolls through space on its side, tilted at an angle of 98 degrees. Imagine a planet lying on its side as it circles the sun, one pole pointing almost directly at our star for half of its orbit, then the other pole taking its turn. This strange tilt means that Uranus experiences the most extreme seasons in the solar system. Each pole gets 42 years of continuous sunlight, followed by 42 years of complete darkness. A single season on Uranus lasts longer than an entire human lifetime. Scientists aren't entirely certain what caused this dramatic tilt, but the leading theory suggests that long ago, billions of years in the past when the solar system was young and chaotic, Uranus collided with another massive object, perhaps an Earth-sized protoplanet. The impact was so tremendous that it knocked Uranus onto its side, where it has remained ever since, rolling through the outer solar system like a cosmic bowling ball, serene and unhurried in its strange, tilted orbit. Fact 8. Neptune's winds. Let's venture to the very edge of the major planets now, to Neptune, the eighth and final planet in our solar system. Out here, nearly 3 billion miles from the Sun, you might expect everything to be still and frozen, moving slowly in the cold. But Neptune defies expectations. Despite receiving only about 1/1000th of the sunlight that Earth receives, Neptune is home to the fastest winds in the entire solar system. In its upper atmosphere, winds scream across the planet at speeds of over 1,200 miles per hour, faster than the speed of sound on Earth. These supersonic winds create storms that rival Jupiter's in intensity. The most famous was the Great Dark Spot, a storm system roughly the size of Earth that Voyager 2 photographed in 1989. Unlike Jupiter's Great Red Spot, Neptune's storms come and go, forming and dissipating over years rather than centuries. No one is quite sure what powers these incredible winds. The Sun is so distant that it provides virtually no energy to Neptune's atmosphere. Instead, scientists believe Neptune has an internal heat source, energy left over from the planet's formation or perhaps generated by the slow gravitational compression of its interior. This heat rises from within, creating currents and winds in the frigid upper atmosphere. As you imagine yourself floating in the darkness near Neptune, you watch those deep blue clouds racing past below, knowing that in that serene-looking atmosphere, forces powerful enough to tear a spacecraft apart are constantly in motion. Fact 9. The frozen frontier. Beyond Neptune, our journey takes us into a realm that few have explored, even in imagination. Out here, more than 4 billion miles from the Sun, we enter the Kuiper Belt, a vast ring of frozen objects that extends far beyond the planets we know. This region is like a cosmic deep freeze, a warehouse of icy bodies left over from the solar system's formation. The temperatures here hover around -370 degrees Fahrenheit, just barely above absolute zero. In this frozen frontier, countless objects orbit in the darkness. Some small, some surprisingly large. Pluto resides here, that beloved world that was once considered our 9th planet but is now classified as a dwarf planet, one of many icy bodies in this distant realm. These objects are time capsules, pristine and unchanged for billions of years, preserving the original material from which our solar system formed. They're made primarily of frozen water, methane, and ammonia, mixed with rock and dust. Occasionally, one of these icy bodies gets nudged by the gravity of Neptune or another object, and it begins a long fall toward the inner solar system. As it approaches the Sun and warms, ice begins to vaporize, creating a tail of gas and dust. We see these visitors from the Kuiper Belt as comets, those beautiful wanderers that grace our skies every few years before returning to the frozen darkness from which they came. Fact 10. The edge of the Sun's embrace. And now, for our final destination in this part of our journey, we travel to the very edge of the Sun's influence, a boundary so far from home that it takes light from the Sun more than 20 hours to reach it. This is the heliopause, the place where the solar wind finally runs out of strength and merges with the interstellar medium, the space between stars. Out here, nearly 11 billion miles from the Sun, our star looks like just another bright point of light in the sky, no longer the blazing orb we see from Earth. The heliopause forms a bubble around our entire solar system, a boundary between what we call home and the vast unknown beyond. Only 5 human-made objects have ever reached this boundary. Voyager 1 and Voyager 2, both launched in 1977, crossed it in 2012 and 2018 respectively. They're now in interstellar space, floating through the galaxy, carrying golden records with sounds and images from Earth, messages in bottles thrown into the cosmic ocean. When Voyager 1 crossed the heliopause, its instruments detected a sudden change. The solar wind dropped away, and the spacecraft began detecting particles from beyond, radiation and cosmic rays from distant stars and galaxies. Standing at this boundary in your imagination, you can look back and see our entire solar system as a single entity, the Sun and all its planets contained within this bubble of influence, this small, protected sphere in the immensity of the Milky Way galaxy. And beyond stretches space so vast that it takes 4 years for light to reach the nearest star. Rest here for a moment. At the edge of everything we know, surrounded by ancient ice, by winds that race in darkness, by worlds turned sideways, by rings of impossible beauty, here at the boundary between the sun's domain and the infinite beyond, let yourself float, peaceful, quiet, safe in the knowledge that you're part of this grand cosmic story, this beautiful, ancient, endless dance of matter and energy. Breathe and rest. Now, let's turn back toward the sun, returning home through the darkness, discovering wonders we passed by on our outward journey, finding beauty in the details we haven't yet explored. Fact 11. The volcanic moon. As we drift back through the outer solar system, let's pause at Jupiter once more. But this time, let's look not at the giant planet itself, but at one of its many moons. Jupiter has 79 known moons, but one stands out above all others: Io. From a distance, Io looks almost cheerful, painted in shades of yellow, orange, red, and white, like a cosmic pizza. But as you draw closer, you realize that this colorful little world is actually the most volcanically active body in the entire solar system. Io has over 400 active volcanoes, and at any given moment, several of them are erupting. These aren't small eruptions either. Some of Io's volcanic plumes shoot material 200 miles above the surface, so high that if you were orbiting Io, you could see the eruptions silhouetted against the blackness of space. The reason for this intense volcanic activity is tidal heating. Io orbits very close to Jupiter, and as it travels in its elliptical path, Jupiter's enormous gravity squeezes and stretches the moon like a stress ball over and over again. This constant flexing generates tremendous heat inside Io, keeping its interior molten and driving those endless eruptions. The surface is constantly being renewed, covered by fresh lava flows, which is why Io has almost no impact craters. Any crater that forms is quickly buried under new volcanic material. As you watch from a safe distance, you can see a geyser of sulfur compounds shooting up from one of the volcanoes, catching the light of distant Jupiter, a fountain of fire and ice in the frozen reaches of space. Fact 12. The hidden ocean. Just a little further from Jupiter orbits Europa, another of the gas giant's moons, and it couldn't be more different from volcanic Io. Europa is a world of ice, its surface covered by a smooth, frozen crust that gleams in the dim sunlight. But Europa's surface tells a story. Long cracks crisscross the ice like a shattered windshield, and in some places, the surface looks chaotic, as if giant chunks of ice have broken apart, shifted, and refrozen in new positions. These features suggest something remarkable. Beneath Europa's icy shell, which may be 10 to 15 miles thick, lies a global ocean of liquid water. This ocean could be 60 miles deep, containing more than twice as much water as all of Earth's oceans combined. The same tidal forces that heat Io also warm Europa, though more gently. The flexing of Europa's interior generates just enough heat to keep that buried ocean liquid, despite surface temperatures of -260 degrees Fahrenheit. Where there's liquid water, there might be life. Scientists believe Europa's ocean floor could have hydrothermal vents, similar to those on Earth's ocean floor, where entire ecosystems thrive in complete darkness, feeding on chemical energy rather than sunlight. As you imagine yourself there, hovering above Europa's cracked ice, you realize that beneath your feet, beneath miles of frozen crust, a dark ocean sloshes back and forth with Jupiter's tides, perhaps harboring life in its cold, deep waters, life that has never seen a star. Fact 13. The rings that vanish. Let's return to Saturn now, drawn back to those beautiful rings we visited before. But here's something magical about Saturn's rings. Every 15 years or so, they disappear. Not literally, of course, but from Earth's perspective, they vanish completely. This happens because of Saturn's tilt and its orbital position relative to Earth. Saturn, like Earth, is tilted on its axis, and as it orbits the Sun, we see its rings from different angles. For most of Saturn's orbit, we see the rings tilted toward us, showing their full glory. But twice during Saturn's 29.5-year orbit around the Sun, the rings are positioned exactly edge-on to Earth. Remember how thin those rings are? Only about 10 meters thick despite spanning hundreds of thousands of kilometers. When they're edge-on, they're simply too thin to see, even through powerful telescopes. For a brief period, Saturn appears in our telescopes as just a golden sphere, ringless and strange. Then, slowly, over the following months, the rings reappear, first as thin lines, then growing wider and wider until they're once again displayed in their full magnificence. This disappearing act happens like clockwork, a reminder that our view of the cosmos is always changing, always shifting, depending on where we stand and when we look. The rings are always there, but sometimes, from our distant vantage point, they slip from view, playing hide and seek across the decades. Fact 14. The backwards moon. As we continue our journey back toward the inner solar system, let's stop at Saturn one more time to visit Titan, Saturn's largest moon and one of the most fascinating worlds we've discovered. Titan is the only moon in our solar system with a thick atmosphere, one even denser than Earth's. But what makes Titan truly special is that it's the only place besides Earth where we've found stable bodies of liquid on the surface. These aren't oceans of water, though. Titan is far too cold for that, with surface temperatures around -290 degrees Fahrenheit. Instead, Titan has lakes and seas of liquid methane and ethane, hydrocarbon compounds that on Earth exist only as gases. Through Titan's thick, orange atmosphere, it actually rains methane, and these methane rainstorms fill rivers that flow into those hydrocarbon seas. The Cassini spacecraft even carried a probe called Huygens that descended through Titan's atmosphere and landed on its surface in 2005. It sent back images of a landscape that looked eerily familiar, river valleys, coastlines, and smooth plains, but made of materials that would seem alien to us. Rocks made of water ice, as hard as granite in the extreme cold. Pebbles made of frozen hydrocarbons. As you imagine standing on Titan's surface, you'd see a dim, orange twilight, the sun reduced to a hazy glow behind thick atmospheric haze. Above you, massive Saturn hangs in the sky, 10 times larger than our moon appears from Earth. And if you walk to the shore of one of Titan's methane seas, you could watch gentle waves lapping against an icy beach, driven by winds in that thick atmosphere. It's a world that's both familiar and utterly strange, a place where the weather cycle works just like Earth's, but with methane instead of water. Fact 15. The smallest planet's secret. Now let's return to the inner solar system, passing Mars, passing Earth, traveling all the way into Mercury, the smallest planet and the one closest to the Sun. You might expect Mercury, being so close to our star to be the hottest planet in the solar system. And during its day, Mercury's sun-facing side does reach temperatures of 800 degrees Fahrenheit, hot enough to melt lead. But here's Mercury's secret. Despite being the closest planet to the sun, it's not the hottest planet in the solar system. That title belongs to Venus. And even more surprisingly, Mercury has ice. At Mercury's poles, inside deep craters that never see sunlight, temperatures drop to minus 300 degrees Fahrenheit. In these permanently shadowed regions, water ice has accumulated, possibly delivered by ancient comet impacts, and has remained frozen for billions of years. So Mercury is a world of extremes, scorching deserts and hidden ice caps, both existing on the same small world. Mercury also has no atmosphere to speak of, which means no weather, no wind, no clouds. The sky is always black, even during the day, and the sun appears 3 times larger than it does from Earth, a blazing disk dominating the sky. Mercury rotates very slowly. One day on Mercury lasts 59 Earth days. This means that if you stood on Mercury's surface, you could watch the sun slowly crawl across the sky, taking weeks to travel from horizon to horizon. Time itself seems to move differently there, stretched out under that enormous sun, in a silence so complete you could hear your own heartbeat echoing in your spacesuit. Let these images settle in your mind. The volcanic fountains of Io reaching for space, Europa's hidden ocean, dark and deep, Saturn's rings appearing and disappearing across the years, Titan's methane rains falling through orange skies, Mercury's ancient ice hiding in eternal shadow. So many worlds, so many wonders. Rest now with these thoughts. Peaceful, calm. We're almost home now, drifting back toward Earth, but there are still a few more secrets to discover. A few more quiet wonders to contemplate before our journey ends. Fact 16, the twin worlds. Let's float past Mercury now and visit Venus, Earth's closest planetary neighbor and almost Earth's twin in size. Venus is only slightly smaller than Earth, and for a long time, scientists wondered if Venus might be a lush, tropical world hidden beneath its thick clouds. But Venus holds no paradise. It's a vision of hell. The atmosphere is 90 times thicker than Earth's, composed almost entirely of carbon dioxide with clouds of sulfuric acid. This creates a runaway greenhouse effect that makes Venus the hottest planet in the solar system, with surface temperatures reaching 900 degrees Fahrenheit, hot enough to melt tin and lead. The atmospheric pressure at the surface is crushing, equivalent to being 3,000 feet underwater. But here's what makes Venus truly strange. It rotates backwards compared to most other planets, and it rotates incredibly slowly. One day on Venus, one complete rotation, takes longer than one Venus year. Venus takes 243 Earth days to spin once on its axis, but only 225 Earth days to orbit the Sun. This means that if you could stand on Venus's surface, you would see the sun rise in the west and set in the east, and from one sunrise to the next would take 117 Earth days. The sky would be a dim, orange-yellow twilight at all times, the sun's light diffused through those thick clouds. Despite its hellish conditions, Venus is often called Earth's sister planet, a reminder of how two worlds so similar in size and position can end up so completely different. Fact 17. The red planet's blue sunsets. Now let's visit Mars, the red planet, that rusty-colored world that has captured human imagination for centuries. Mars is cold and dry now, with temperatures that can drop to minus 200 degrees Fahrenheit at the poles. Its atmosphere is so thin that it's almost a vacuum, less than 1% the density of Earth's atmosphere. But Mars has something beautiful to offer, something that would take your breath away if you could witness it in person. On Mars, the sunsets are blue. While Earth's sunsets paint the sky in reds, oranges, and pinks, on Mars, The sun sets in a blue glow surrounded by reddish-brown twilight. This happens because of the fine dust suspended in Mars's thin atmosphere. These dust particles are just the right size to scatter blue light, the opposite effect from Earth's atmosphere. As you imagine yourself standing on Mars's rusty plains, perhaps in Gale Crater where the Curiosity rover has explored, you watch the sun sink toward the horizon. The sky, normally a butterscotch color during the day, begins to shift. Around the sun, a blue halo forms, deepening to a rich azure as the sun touches the horizon. For a few minutes, you're bathed in blue light on the red planet, a moment of unexpected beauty in that cold, harsh environment. Then the sun disappears, and within minutes, the temperature plummets, and the stars come out in a crystal-clear sky, unmarred by light pollution or thick atmosphere. Fact 18. Earth's cosmic companion. And now we return to Earth, but let's not go to the surface quite yet. Let's pause at our moon, that faithful companion that has orbited Earth for over 4 billion years. The moon is gradually moving away from Earth at a rate of about 1.5 inches per year. This happens because of tidal forces, the same forces that cause ocean tides on Earth. As Earth's oceans rise and fall with the tides, friction slows Earth's rotation ever so slightly, and through a complex transfer of angular momentum, the moon's orbit gradually expands. Billions of years ago, when the moon first formed, likely from debris created when a Mars-sized object collided with early Earth, it was much closer, perhaps only 15,000 miles away instead of its current distance of 238,000 miles. Back then, the moon would have appeared enormous in Earth's sky, more than 20 times larger than it does today, and tides would have been hundreds of feet high. Over time, the moon has slowly spiraled outward, settling into the orbit we know today. But it continues to drift away, and will continue doing so for billions of years. Eventually, in the far distant future, the moon will be so far away that it will no longer be able to cause total solar eclipses. Right now, we live in a special time when the moon and sun appear almost exactly the same size in our sky, a cosmic coincidence that allows us to witness those breathtaking total eclipses, when the moon perfectly covers the sun. Fact 19. The pale blue dot. Now, finally, let's turn our attention to Earth itself, but let's view it the way the Voyager 1 spacecraft did in 1990, from beyond Neptune's orbit nearly 4 billion miles away. From that distance, Earth appears as a tiny point of light, less than a pixel in the photograph. A pale blue dot suspended in a sunbeam. The astronomer Carl Sagan, who suggested that Voyager take that photograph, wrote beautiful words about it. On that, every human who has ever lived has lived out their lives, every triumph and tragedy, every civilization, every war, every moment of love and courage and discovery. Everything we've ever known exists on that tiny, fragile point of light, floating in the vastness of space. From out there, Earth doesn't look special. There are no continental boundaries visible, no signs of human civilization, nothing to indicate that this world is any different from countless other planets that must exist among the stars. But it is different. It's our home. It's the only world we know of that harbors life, the only place in the entire universe where we know with certainty that matter has organized itself into consciousness and looked back at the cosmos with wonder. That pale blue is covered mostly by water, wrapped in a thin shell of breathable air, warmed by a stable yellow star, protected by a magnetic field. It's the product of billions of years of cosmic evolution, from the Big Bang through the formation of stars and galaxies and finally our solar system. And on its surface, life has flourished in extraordinary diversity, from microscopic bacteria to blue whales, from ancient redwood trees to human beings who build telescopes and spacecraft to explore the cosmos. Fact 20. The cosmic dance continues. And now, as we complete our journey, let's pull back and see the entire solar system as one connected whole, a family of worlds bound together by gravity, born from the same cloud of gas and dust 4.5 billion years ago. Every planet, every moon, every asteroid and comet is part of one system, dancing around our sun in orbits that have been refined over billions of years into a stable, elegant arrangement. This dance continues, silent and eternal. Mercury completes its quick orbit every 88 days. Venus takes 225 days. Earth takes 365 days, 1 year. Mars takes 687 days. And the outer giants move so slowly. Jupiter takes 12 years, Saturn 29 years, Uranus 84 years, and Neptune 165 years to complete one orbit. Right now, at this very moment, all of these worlds are moving through space, following their ancient paths. The Sun continues to fuse hydrogen into helium in its core. Earth's magnetic field continues to shield us from the solar wind. The storms on Jupiter continue to swirl. Saturn's rings continue to orbit. And countless other processes continue throughout the solar system. Processes that have been happening for billions of years and will continue for billions more. We are part of this dance, spinning on Earth as it orbits the Sun, as the Sun moves through the Milky Way galaxy, as the galaxy itself moves through space. Everything is in motion, everything is connected, and everything is part of one grand cosmic story that began with the Big Bang and continues unfolding today. And you are part of that story, made of atoms forged in ancient stars, living on a world that's just the right distance from its star to support life, conscious and aware, able to contemplate your place in this vast universe. And now, as our journey comes to an end, let yourself rest, knowing that above you, beyond the atmosphere, the cosmic dance continues. The planets orbit, the sun shines, the moon drifts slowly away, and countless worlds you'll never visit exist in the darkness, each with their own stories, their own secrets. You are home now, safe, peaceful, part of something vast and ancient and beautiful. Let these thoughts dissolve. Let your mind grow quiet and drift into sleep under the same stars that have watched over Earth for billions of years. Rest and dream of the cosmos,